Hi guys, in this video we're talking about 3x3 simultaneous equations, and we're going to be using some sort of elimination method with matrix shorthand to try and find an answer. Now this is opposed to using inverse matrices to try and solve simultaneous equations. So this method might remind you of what you did in school, like try to get rid of some of the letters. We're going to try and eliminate z from both of these equations here, both the second and third equations. And we're going to also try and eliminate y from the third equation. So ideally, we want the third equation to only have x in it. So we'll know x from that. The second equation will have x and y in it, and we can work backwards. If we know x, we can then find y. And then the first equation, well, it'll have x, y, and z, but if we know x and y, we'll be able to get z too. Cool. Now, let's just have a go at this. Let's just jump straight in. The current second equation has got 3z, and this equation's got z. So what I could do is I could take equation 2 and I could add 3 lots of equation 1, and that would help me eliminate z. So I would have x minus 2y plus 3z plus 3 lots of x plus y minus z. So that's equation 1. And then I could have the right hand side, which is minus 6 plus 3 lots of 4. If I tidy that up, I'm going to get x plus 3x is 4x, minus 2y plus 3y is y. And over on the right hand side, I've got minus 6 plus 12, which is 6. Cool. So I'm going to call this equation 2a. So it is still that second equation, but I've made some slight changes to it. I'll also do that with the third equation as well. So let's have a look at the third equation. 2x plus 3y plus z. There's a single z here. If I calculate equation 3 plus equation 1, that should help me get rid of the z, since there's a positive z here, minus z there. So let's do that. Equation 3 plus equation 1 is going to be 2x plus 3y plus z plus x plus y minus z, and the right hand sides are going to be 7 and 4. 2x plus x is 3x. 3y plus y is 4y. And the z's cancel out, and I get this. 3x plus 4y is 11. And that's my edited equation 3. So I'm going to call that 3a. I've changed it once. Now let's copy this system of equations, but let's include those changes. Let's scroll down. Let's write it down here. So I've changed equation 2 now. It's now 4x plus y. Oops, that's not it. 4x plus y equals 6. And the bottom equation has become 3x plus 4y equals 11. Cool. So now what I can do is just focus in on these bits. I'm sort of zooming in on that bit, and I should be able to work out what that is. Just that system of 2x2 simultaneous equations. Right, so let's see. If I times this equation through by 4 and subtract it from this equation, I should be able to get rid of the y's. So I'm going to take equation 3a, I suppose, and I'm going to take away 4 lots of equation 2a. Let's see what that turns out as. 3x plus 4y, take away 4 lots of 4x plus y, And I'm going to have on the right hand side 11 take away 4 lots of 6. So the x's, I'm going to have 3 take away 4 times 4 is 16. So I'm going to have 3 take away 16 is minus 13x. And for the y's, well, they should cancel out. 4y, take away 4y, yes. Okay, right hand side. 11 take away 24, 11 take away 24 is minus 13. All right, cool. So well, I can work this out. Minus 13 times something is minus 13. X must be minus 1. And if I just work my way back up these equations now, actually, let's just write this down, but with that final change, I guess we got this out. There we go. So we got that out. We've got x. So now that we know x, we can then sub it in to the equation above. So we can say 4x plus y is 6, x is 1, so chuck that in there. And then we can see that y should be 2. Finally, you can go a little bit further up again, and you can plug x and y into the top equation. So x was 1, y was 2, z we don't know yet. Let's make that clearly a z. There we go. 3 take away z is 4. Z must be minus 1 to solve it. So then I have the solutions. X, y, z should be equal to 1, 2, and minus 1. Cool. Now, if I do something similar, but write it with this shorthand, you might find it's a little bit easier to follow. So let's just try that quick. So it's the same principles. We're still trying to get rid of the z's. So effectively, we want zeros in this column. But just not having the x, y, z's there, it just makes it a little bit simpler. So let's treat these as row 1, row 2, row 3. And I want to replace row 2 with a bigger, better row 2. I'm going to do exactly as I did over on the left hand side. I'm going to take the old row 2 and I'm going to add 3 lots of the current row 1. So I'm just looking at these bits along here. And you might find this easier to do mentally. So let's just keep this top row exactly as it is. This second row, well, so I'm going to do 1 plus 3 lots of this. So mentally in my head, I'm just doing 1 plus 3 times 1, which is obviously 4. I'm going back here again, minus 2 plus 3 lots of 1, that's 1. 3 plus 3 lots of minus 1, that's 0. And hopefully, and same over here on the right hand side, minus 6 plus 3 lots of 4, that is minus 6 plus 12 is 6. So you can see a similarity between what we have. Let's have this nice shade of blue here with what we have here. But it might be a little bit easier to follow because you don't have to write out the x, y, z the whole time. Let's also replace row 3 with something shiny and new. And again, we're trying to get rid of the z's. So we're looking at the 1 here and the minus 1 here. Oh, we could add these rows together and replace row 3 with it. So it's going to be the old row 3 plus row 1. And I'll just write that here. So 2 plus 1 is 3. 3 plus 1 is 4. And 1 plus minus 1 is 0. And 7 plus 4 is 11. So a lot simpler, a lot easier to think about what the answer is going to be. Don't have to write it all out. Happy days. So, to get the answers, we're just repeating that process, but we're going to try and eliminate this element here. And it's the exact same calculation as we had just now. So let's just write down that again. 1, 1, minus 1. So this top row is fixed now. So is the second row. And we're going to change row 3 once again. And we are going to take away 4 lots of row 2. So mentally, I'm looking at this, I'm doing 3 take away 4 times 4. 3 take away 16 is minus 13. 4 take away 4 lots of 1 is 4 take away 4, which is 0. And because both of these elements are zeros already, I don't really have to do anything. It's just 0. 11 take away 4 lots of 6. 11 take away 24 is minus 13. Cool. And this is row echelon form. So you can see in terms of the elements of the matrix, we have things sort of forming like a triangle in your matrix. Right, so you have a upper left triangle with elements that aren't 0, and you have a lower right triangle that are all zeros. And if you have a system like this, you can easily work out what the solutions to the simultaneous equations are, just reading backwards. So just to finish off, let's just write this system here as equations with x, y, and z in them. So we've got this top equation, which says 1x plus 1y take away 1z is 4. The second equation, which says 4x plus y is 6. And the bottom equation, which says minus 13x is equal to minus 13. Now, hopefully it's easy to see from this one what x should be. Oh, that's not right. Oh God, that's not right. There we go, that's right, that's better. Right, so we can see what x should be, clearly 1, not minus 1. And then we can plug that in to the equation above it. So we can take the middle equation, 4x plus y is 6, but we can replace the x with a 1. And we can solve that. And then we get a value for y. And then once you have that y value, you can go back to the top equation, x plus y take away z is 4. You can sub in x and y. And you can get something out there. So 3 take away z is 4. That means z is going to work out as minus 1. There we go. And we have our solution, x, y, z, which are 1, 2, and minus 1. There we go. There it is.